Okay guys, not sure what's going on here, but this is my third attempt at this, so hopefully this video turns out a little bit better. Having some technical difficulties today with my computer, so let's cross our fingers. Alright, so we want to try to solve this equation. So I notice here that I've actually got an equal sign today, not just an expression, so I've got both sides I've got to work with. If I want to solve an equation that's a quadratic, has an x squared in it, there's some different methods that I can use, but no matter what I use, I want to get it equal to 0 first. So one thing that's important is I always want to make sure my lead coefficient, so my coefficient of my x squared is positive. This one already is, so that means I want to move everything else to that side. I want to leave the x squared where it's at and move everything else to that side. So I'm going to go ahead and I'm going to add 58x, and I'm going to add 30 while I'm at it. Okay, so let's get that line out of the way. Made that guy a little too long. Over on the left side, 24x squared. Can't combine that because they're not like terms. They don't both have x squareds. Plus 58x plus my 30. All of that now over here on this side looks like I've only got a 0 over there. So all that's equal to 0. Now once I get this far, I'm going to go ahead and I'm going to factor my quadratic, just like we did in previous days. So I'm looking at all three terms and I see that there's a greatest common factor of 2. So I'm going to bring a 2 out front. So 2 comes out front, 12x squared plus 29x plus 15, still equal to 0. Okay, what's kind of nice, before we had to bring that 2 along. Now since I've got an equal sign, I can work with both sides at the same time. So I'm going to divide both sides by 2. Kind of a small step. May not seem like it's really that important, but now I just don't have to worry about that guy. He's gone. 12x squared plus 29x plus 15 equals 0. Okay, now I'm ready to go to my chart. So top of my chart, ways to get 12x squared, 1x, 12x, 2x, 6x, 3x, 4x. Bottom of my chart, ways to get 15. Remember that equals 0 is over on the other side, so we're focusing on this 15 on the side with all the x's. 1 and 15, 3 and 5. Since I'm not balanced up here, I need to flip them around. 5 and 3, 15 and 1. Looks like signs are going to be the same, so we want them to add to be 29. Well, some of these are going to be pretty big. 12 times 15, that's already bigger than 29. We can't add anything to that. Same with 12 times 5, 12 times 3. So now I get down here to 12 times 1, it's 12. 1 times 15, that's 15. So I get 12 plus 15, that's not 29. So my 1 and 12 are out. Okay, 6 times 15, way too big. 6 times 5, that's still 30, that's still bigger than 29. 6 times 3 is 18. 2 times 5 is 10, 18 and 10 is 28, not 29. Okay, last one with the 6 and the 2. 6x and 30x. That one does not work. That one's out. Last pair to try, I've got my 4x and my 3x. 60x, way too big. 20x, oh, and 3 times 3 is 9, so I've got 9x and 20x. Those work to give me add to 29. So coming back over here, put it in my form, my factored form, into my 2 binomials. First comes from the top. My last terms come from my bottom, and it looks like 3x is connected to 3. So I'll FOIL 3x I want connected to 3, 4x I want connected to 5. Signs we said were the same, both were positive. Okay, so we factored this. But we still need to solve this equation. Well, if I look at this, I've got something times something equals 0. If I think back to the zero product property, I know that if I'm multiplying two things together, at least one of those things, one of those factors has to be equal to 0. So what that tells us is it tells us either my first factor, 3x plus 5, equals 0, or my second factor, 4x plus 3, equals 0. So it looks like I'm going to have two possibilities. I'm going to go ahead and I'm going to solve those. 3x equals 5, negative 5. X equals negative 1 and 2/3. Or, got to solve our other one. x equals negative 3/4. So I've got two possibilities. Anytime I've got a quadratic, I should have two possibilities because of what we'll see on our graph in a later video. There are some special cases that I may only have one or none, but we'll talk about those later on.